Analysis of the transformation of matter in chemical processes. Solution to the problem situation. Team number 4, progress report 1. So being a student of the study of matter can be difficult, and we feel a great attraction towards science. It is well known that there is a learning curve, and as we move forward, concepts will get more and more complex. We find ourselves often relating previous principles to new ideas, and this is why we must have solid foundations to have a deeper understanding on future concepts. Stoichiometry is a branch that wishes to quantify all the types of relationships between the reactants and the products, the different types of chemical reactions that exist, and making the number of atoms the same on both sides, also known as balancing the reaction, are the foundations of this branch, given that it is needed to calculate molar ratio, the amount of product or reactant that will be produced based on the concentration of one or the other. Thanks to molar ratio, we can determine limiting reactant, they're responsible for preventing the making of more products. Based on the result, we can obtain the reaction yield, which is generally referred to as the ratio of the number of good products fabricated in a reaction and its relationship between the initial compounds. So in chemical equilibria, when its Kc constant is equal to 1, this means that the amount of reactants will be the same as products. The equilibrium concentration only depends on gases, and it has allowed us to comprehend how changing the concentration, pressure, or temperature of a particular reaction will affect its results. It often wishes to tackle questions like, is there a way to favor the making of the product? How will changing the temperature affect the amount of products produced? This is referred to as the Le Chatelier's principle, which states that if a system at equilibrium is disturbed, the system will shift its equilibrium position to counteract this effect. Another important concept is pH. An acid, which has a pH of less than 7, is a proton donor, while a base with a pH of 7 or higher is a proton acceptor. In other words, a base is a substance that can donate and accept a couple of electrons. So chemical kinetics is a branch that studies the velocity at which a chemical reaction takes place. The area focuses on the rate of reactions, and depending on how the reacting concentration affects the concentration of the products, we can determine what order the reaction is. Once we know the order of the reaction, we can determine the rate, the concentration of the reactant at any given time through the integrated rate law, the graph of the reaction with respect to time, and the time it takes to reduce the initial concentration by 50%, also known as half time. So every topic seen in class is extremely motivated. I managed to achieve a profound knowledge of all these concepts and apply them not only in the problem situation of this class, but in the real life and other classes, such as my thermodynamics class. So I leave this class with so much knowledge and appreciation for my teacher in hopes that our paths cross again soon. And these concepts will help me as a professional, and I will continue to maximize the knowledge given by my courses, that I can make a positive contribution to my community and hopefully my country.
Analysis of the transformation of the matter in chemical processes. Team number 4, report number 2. The prevailing situation is a family business dedicated to production of ethyl acetate. This substance has many applications as it's used as an ingredient in different commercial products such as nail polish remover, aroma enhancement in food and perfumes, as well as in the manufacture of paints, varnishes, solvents, inks, and glues. The owners of the companies have found that eliminating the amount of water produced could favor the production of the ethyl acetate, but they do not know if they will work. In order to solve this consulting case, it is necessary for us to carry out the investigation. So, according to the chemical reaction, are the amounts of ethanol and acetic acid need to produce ethyl acetate the same? Does this mean that to produce 1 ton of ethyl acetate, 1 ton of each reagent is required? Is this correct? According to the calculation, we can see each reactant have a different ability to produce the product. This means that there always exists a limited reactant, which will cause the amount of product created will be less than the other reactant, called the excess reactant. So the amount of reactants needed to produce 1 ton of the product won't be the same. The company have 500 liters of ethanol and 500 liters of acetic acid in the inventory. What is the maximum amount of ethyl acetate that will be produced? Well, as we can appreciate, we have more acetic acid than ethanol. So in this scenario, the limiting reactant will be the ethanol, allowing us to create a total of 754.69 kilograms of ethyl acetate, which will be the hypothetical yield in this reaction. Could you explain if the production of ethyl acid can be increased by removing the water from the following reaction? Well, decreasing the amount of water in the system produces some change in the concentration of the product of the water. Therefore, so that can be balanced. It will move to the right of the production of the product, increasing the ethyl acetate more and compensation for the product eliminated. Yes, effectively eliminating the water and decrease of the product ethyl acetate and taking into account that all the substances in the reaction are liquid at the room temperature, how could the water can be eliminated? Well, to remove water, we could use the process of distillation so the liquid on the lowest point could evaporate. But ethyl acetate is liquid, and by evaporating, we could lose some ethyl acetate in the process. Thus, it will be better to use drying agents that will only remove water from the compound. Some commonly used drying agents in laboratories are calcium chloride, sodium sulfide, and finally two types of magnesium, which are magnesium oxide and magnesium perchloride. Do you think there is another way to the power of production of ethyl acid? For the reaction, changing the concentration of the products and reactants of increasing total pressure might change the equilibrium component. However, the value of the equilibrium constantly hardly changes. This is because of all the components in the reaction are in liquid form. Thus, in changing the volume of the container will not affect the product. Nevertheless, if the forward reactions in the is endothermic, meaning that the heat might be theoretically considered as a reactant, increasing the temperature will increase the value of the equilibrium constant, resulting in more favorable conditions for the production of ethyl acetate and increasing uh, the amount processed.
Hi, I'm Renato Portillo, and I'm going to talk about green chemistry. The green chemistry helps the world by designing products or making the chemistry production of a product to be more green to the world and to us. Green chemistry can be used in each part of the cycle of the life of the product. It can be either the design, the manufacturing, the use of the product, and even the disposal of it. Ethyl acetate is a cleaner solvent than most of the solvents that are used in the world. Thanks to this solvent being greener, the disposal of it is better for us and its process of degradation is quicker. Green chemistry is what will make the world a better world. And even though everyone knows about it, I believe that most of the products aren't that mainstream. This class taught a lot of things that I didn't know about before and made me learn more things about chemistry.
Hi, my name is Jose Pablo and I'll talk about the advanced 4 of the problem situation. So, we are talking about chemical kinetics. To talk about this topic, we need to know about certain topics like which order of the reaction we'll be talking about, how the concentration of the reactants will affect in the rate of production of the products, and in this case the ethyl acetate. And by knowing this, you will know how to fasten the reaction or know how fast the reaction is going. So if you want to know how fast is ethyl acetate produced, you will need to know the order of the reaction, the concentration of the reactants, and the temperature to know how the ethyl acetate will be produced. And knowing this, you may know how to accelerate the production of ethyl acetate by knowing, the order of the reaction, if it's zero order, first order, second order. And by knowing this, you will now know how to accelerate the reaction of the products. And overall, the class, a little summary. I enjoy very much this class. I now know a lot of things I didn't know in the past month, and I'm very thankful for this class. It's been an honor, and and I enjoy it very, very much. Thank you.